Hi everyone, let's do section 1.3 on basic graphs and symmetry. We're going to prevent you from having to do too much point plotting, so these will be your friends. It will be good for you to learn a basic gallery of graphs, and symmetry is your friend. It'll save you time when graphing. In particular, we're going to graph a lot of power functions. Functions whose rules look like f of x equals x to the n, where n is some real exponent. In fact, by the end of this section, you should be able to graph anything of the form y equals x to an integer. Now, the first functions we're going to look at can be thought of as some basic examples of these, maybe. What are some examples of very lazy functions? Functions that aren't very creative with their outputs. What are some very basic lazy functions? Why don't we start off with constant functions? F of x equals c, where c is some real number, like 3. Take f of x equals 3. Well, how would you graph the line y equals 3? It's going to be a horizontal line. Here's a graph of y equals 3. This graph represents the function 3. Notice it passes the vertical line test. This is a function. Now, people might say, well, is it really a function of x? I mean, it doesn't really depend on x. Well, that's a semantic issue. Still, we say that f here is a function, even though x is not involved with the rule here. Another way you can see it's a constant function is that whatever the input is, 6, -10, whatever, the output's going to be 3. So the input could be 1, and the output is 3. The input could be pi, and the output is 3. The input could be -3, and the output is 3. Every real input will yield the same output, 3. So that's an example of a very lazy, uncreative function. What's another example of a lazy function? And I'll give you a hint. Group work, where you do a bunch of work and you pass it on to somebody. That person might just copy your work. Hopefully not. But let's talk about identity functions. All right. Basically, an identity function has the form f of x equals x. Why is it called the identity function? Because the output is identical to the input. Whatever the input is, that's what the output's going to be. So if you give your partner 6, your partner spits out 6. Doesn't do anything. If you give your partner 10, your partner spits out, -10. If you give your partner -10, your partner spits out -10. Basically, this function is not doing any work. It's just passing on what you give it. That's an identity function. How do you graph y equals x? Or x to the first? It's a very basic example of a power function. Well, you graph y equals x as the slanted 45-degree line. If you input 1, you output 1. If you input 2, you output 2. If you input -1.5, you output -1.5, and so forth. If you input 0, you output 0. This is an odd function, as we'll see later on. Why do I use the plural? Because technically, the domain could be restricted. It doesn't have to be all real numbers. But we're going to assume for now that the domain is R, all real numbers. Another lazy function. Now, this here is also an example of not just a power function, but a linear function. Okay. In general, we have a linear function if we have something like f of x, or it could be g of t or something, but f of x equals mx plus b, where m is the real slope and b represents a y-intercept. It's a real number that represents a y-intercept. Where m is not 0. If m is 0, you're just left with what kind of function? A constant function. And then you're back to this horizontal line here, right? That kind of horizontal line. So for a bona fide linear function, we assume that the leading coefficient m is not 0. And we saw a lot of these in section 0.14. Remember? We graphed a whole bunch of lines. So for example, if you have f of x equals 2x minus 1, well, how do you graph y equals 2x minus 1? Okay, you'd graph it as this slanted line here. So again, the identity function is an example of a linear function, but there are many more. Next up, we're going to look at some nonlinear functions and ideas of symmetry.